Hey guys, I got a new Numworks calculator and I figured out how to evaluate each of these using the Python application. We have 7 double factorial, 8 triple factorial, and the square root of 5 factorial. So basically double factorials, triple factorials, and non-integer factorials. So first let's talk about what each of these things mean. Let's look at some examples. So something like a single factorial, 5 factorial means 5 times 4 times 3 times 2 times 1. And 4 factorial means 4 times 3 times 2 times 1. So basically we go down by 1 each time. And whenever you're doing single factorials, you always stop when you get to 1. And 0 factorial is defined as 1. It doesn't follow the same pattern, but it's still equal to 1. And if you're curious about this, I have some other videos going over this, and so do a lot of other people. In a double factorial, you go down by 2 each time. 8 double factorial will be 8 times 6 times 4 times 2. You go down by 2 each time. And 7 double factorial would be 7 times 5 times 3 times 1. And when doing double factorials, you always stop when you get to 2 or 1. So now for triple factorials, 9 triple factorial would be 9 times 6 times 3. You're going to go down by 3 each time. And 8 triple factorial is 8 times 5 times 2. For triple factorials, you stop when you get to 3, 2, or 1. And for non-integer factorials, this is a little trickier to explain, but we got this. First, let's look at it in Desmos. Here's the first 5 integer factorials. Let's plot points for each of these. So 0 factorial equals 1 is the point 0, 1. 1 factorial equals 1 is the point 1, 1. 2 factorial is equal to 2 is the point 2, 2. And 3 factorial equals 6 is right here at 3, 6. And 4 factorial equals 24 is right here at 4, 24. These are some of the integer factorials. Now to do a non-integer factorial, we got to figure out what are the gaps in between these. How do we decide what we're going to use to fill in the gaps? There's a really cool function called the gamma function, and it's defined like this. And it has one really neat property. The gamma of x plus 1 is equal to x times the gamma of x. This is similar to the relationship that integer factorials have with each other. So if we graph y equals gamma of x plus 1, it gives us this right here. Notice how it ends up going through the first 5 integer factorials. And if we were to zoom out, it does go through every single integer factorial. And now using this function, we can evaluate factorials in between the integers. So for example, here is the line for x equals square root of 5, and we can see that it intersects at about 2.51348. And this blue line is the line for x equals 0.6, and we can see that it intersects at about 0.89352. So those are the approximate values of these 2 non-integer factorials. But I figured out how to evaluate it in this calculator without having to look at a graph in Desmos. And here's the code right here. I would show you the code on here, but Numworks has this really easy way to do it online. You can just hit edit, and not only can you do the code right here, but you can also test it right here. And this is all free for anybody to access online. So I'll show you the code in a second, but I'm kind of excited to show you it working. So 4 factorial will give us 24. So there's 24.0. So something like 6 double factorial would be 6 times 4 times 2 is 48. And that works. And if we do a triple factorial, let's go 8 triple factorial. That'll be 8 times 5 times 2. That'd be 80. And it gives us 80. So we have single, double, and triple factorials. Let's do the square root of 5 factorial. And it gives us the 2.513, etc. Pretty cool, huh? And it also works on the calculator just like this. So I'll show you the code really quick. So first for the single factorial, the one that did the 4 and the root 5, I used the gamma x plus 1 function. So for the double factorial, I had to take your number, whatever you input, go down by 2 each time, and then it stops when it gets to 1 or less. And then for the triple factorial, it starts at your number, goes down by 3 each time, and then that'll stop when it's equal to 1 or less. And then here's the prompt that it gives you. It says enter n factorial, n double factorial, or n triple factorial. That is what shows up right here. And then all this right here counts the number of factorials you put into it, whether it's 1, 2, or 3. And this last part is the error messages. So if you did something like a quadruple factorial, so if we do like 9, 1, 2, 3, 4, that ends up giving an error. It basically says use 1, 2, or 3 exclamation marks. I guess I probably should have said factorials. I can change that. So instead of 1, 2, or 3 exclamation marks, I can say 1, 2, or 3 factorial. And then I'll save it, and then we can look at it again. Now when I get an error, 9, 1, 2, 3, 4, it says use 1, 2, or 3 factorials. And then if you do something just like 45, it says use some number of factorials. So this is the code for all the factorials.py. And if we want, we can load it right to our calculator. You just got to plug the calculator in with this cord and then just hit load to calculator. And it works immediately. There it is right there, all the factorials. And I can execute it on here. And here's all three of them right on the calculator. So I'm really digging this Python functionality. It's pretty fun. Right now, Numworks is having a promotion where high school math teachers can get a free calculator. It'll give you a chance to play around with the Python application. You can visit numworks/andymath to access the promotion. How exciting.